Welcome to Basic Brewing Radio for March 3rd, 2011. I'm James Spencer. Here at Basic Brewing Radio, we're all about home brewing. Well, this week we examine the data from the 7th Brew Your Own magazine Basic Brewing Radio Collaborative Experiment. When does an iodine test indicate starch conversion in the mash, and what does that mean? If you're new to home brewing and would like to get into the hobby for the first time, check out our website, basicbrewing.com, where you can find archives of our audio and video podcasts and our DVDs to walk you through basic and more advanced brewing techniques. You can find me on Twitter. I'm Basic Brewing, all one word. On Facebook, I'm at facebook.com/basicbrewing.james. And our show page on Facebook is at facebook.com/basicbrewing. Thanks again to everybody clicking on the Amazon.com associate link on our basicbrewing.com site. Whenever you think of Amazon, think of us and click on our associate link first. It won't cost you any extra, and you'll be helping us to bring you the show, and we appreciate your support. We also have associate links for Brew Your Own magazine and the American Homebrewers Association on our site, too. And, as always, you can find our iPhone and Android podcast apps on their respective stores. And BlackBerry users, find us on your BlackBerry podcast directory, too. Well, let's go straight to the topic this week. We talked a good long time because there's a lot to go over. For the 7th BYO-BBR collaborative experiment, we asked you to take a starch test of a mash every 5 minutes to see when it indicated conversion. And even though we gave you a fairly short time period, we received amazing response. And I got together with Chris Colby, editor of Brew Your Own magazine, along with homebrewers Zot O'Connor and Kai Troester to go over the results. Well, I want to welcome back to Basic Brewing Radio, Chris Colby.
Hey, James.
And Kai Troester.
Thanks for having me on again.
And we've mentioned him before, but this is the first time that he's been on the show, Zot O'Connor.
Thank you, James.
This is all your fault that we're here, Zot. This is all your idea.
Well, I never told you the genesis of the idea was when Chris made that mention that, you can saccharification can happen in 10 minutes or less or something like that on a podcast. My immediate reaction was, really? I can bet I can prove that or not to you. It wasn't a very scientific, really, response, but it was really much more of a knee-jerk, if I could comment, it would be "you suck" kind of response. Like, hey, you're stating an opinion, and I can go after that. And I realized that makes it a good challenge and experiment.
Oh, well, there you go. So
I blame Chris.
It came out of spite.
It's my fault.
Well, it was a good idea, apparently, because this experiment garnered the most attention and I guess the most effort, even though we wanted it to be the easiest experiment. A few of these guys took this to an extreme and made it the most elaborate execution of any that we've had. We had, besides us four, we had 16 brewers out there from across the country and around the world. So I want to congratulate all the Basic Brewing Radio, Brew Your Own magazine listeners and or readers out there who participated. You guys are awesome. The data is massive, and we can. As we were speaking before I started recording, it's both wonderful and daunting that there is so much data and that it is so kind of messy because it is kind of all over the place. But before we get into analysis, maybe we should start back in the beginning and talk about what we're measuring here. So, Chris, do you want to talk a bit about sort of the mash mechanics? I mean, what's going on inside a mash tun when you have malted grain interacting with water at a certain temperature?
Yeah, well, the basic idea behind this experiment is we wanted to measure. There was two things. We did the iodine test and refractometer readings or hydrometer readings over time. And the basic idea is in the mash you've got your malted grains, which are mostly carbohydrate. There's the starch in the endosperm of the grain. And it's got the husk, there's proteins and there's other things, but it's mostly carbohydrates. That gets crushed, it gets added to hot water, and the starch starts to dissolve, and once the starch dissolves enough that it's accessible to the enzymes, the malted barley has enzymes in it, which as a percentage of their entire weight is very, very small, but an individual enzyme can go catalyze many, many reactions. And so what happens is, the starch starts to dissolve. The enzymes, specifically amylase enzymes, attack the starch and degrade it into sugar. And one method of determining how far this reaction has proceeded is the iodine test. And basically, the iodine test is something that if you've ever taken a chemistry class, you've probably done the iodine test where you grind up a little bit of a potato and you put the iodine test in there and it turns, purple and shows you there's starch. Same exact idea in brewing. You take a little bit of wort from your mash, you add a tiny bit of iodine to it, and if it turns like a black or a purple or a blue, that's an indication that starch is there. If it doesn't, or if it turns like a duller sort of red or whatever, that means there's less starch there or no starch there. And so, our idea was have people, in their brew day, take iodine readings every 5 minutes, and also take either a refractometer reading or a hydrometer reading every 5 minutes, and just see, how long does it take till we reach, a negative iodine test, and also what is the specific gravity or what's the reading in Brix if you're using a refractometer of your mash over time.
So I guess the assumption going into this was that, or one of the questions that we were asking is, when the starch test turns negative, does that mean the mash is over? And if we can get a starch test to turn negative in, say, 10 or 15 minutes, does that mean that we can save the rest of that hour or hour and a half that we would have spent and go ahead and start, taking our wort from the mash? Kai, do you have anything else to add kind of on the background before we start and going into the data?
So I just want to mention or bring people up to speed how this iodine test actually works and where's this color reaction coming from. And to understand that, we have to look at these glucose chains that are part of the starch or the large dextrins, that they have the tendency to coil up in little helices like screws. And when they do that, then the cavity that is formed is just about right for a so-called triiodine ion to fit in there. So that's 3 iodine atoms together, and they are one ion. And they fit in there. And the more that fit into this helix, the darker the color of the iodine reaction will be. So if you have very long glucose chains, you get this really dark black, dark blue reaction. As these glucose chains get shorter, the reaction goes more towards a reddish color. And then once the glucose chains are shorter than 9 glucose molecules, they would stop because the iodine doesn't fit in there anymore. And that's how we can use it to test when the vast majority of these glucose chains that came from starch have been converted to dextrins or to smaller sugars in the mash. And it's important to get to that stage because the really long dextrins, they can form a so-called starch haze in the final beer. And if we don't convert them while the enzymes are still active in the mash, then we could carry over that haze into the beer, because obviously those enzymes that would degrade them, they are denatured during the boiling process.
So you can get, using the starch test, you can kind of, it's not an all or nothing indication. You can kind of see how it's progressing as the mash goes along.
Yes, you can to some extent, but because it's such a mix of branched and non-branched dextrins in the mash, as opposed to having like a pure solution of a particular form dextrin. It's oftentimes very fuzzy, trying to read too much into that. So the idea is to get no color reaction from the word when iodine is added. And at that point, the word is called to be iodine negative.
Mm-hmm. So Kai, what's the key to getting a good iodine starch test?
Well, for one, you need a solution that actually has free iodine. And the first solution that kind of was made like that is what was called Lugol's iodine, and it's a mixture between it's a mixture between potassium iodine and iodine, and that makes this iodine soluble. And you can mix this sort of Lugol's iodine. You can actually buy it at health stores. You can mix that with about you take 1 part of this iodine solution and 9 parts of rubbing alcohol and mix that to make a starch test solution. And the idea of diluting that iodine solution is that because it has such a strong color, you want to cut down on that color so you don't really mistake the color of the iodine for a color reaction. But most people these days just use iodophor. I, for example, still have a big bottle of iodophor, which I used to use as a sanitizer. You can dilute that with rubbing alcohol in like 10 to 1 as well. Or you can use any iodine solution that you can actually find in the pharmacy. But you have to make sure that you actually get a product that actually has iodine in it, and it's not a substitute. Because the thing with iodine is that iodine is used in meth production, and that has led to the restriction of sale of iodine. But it seems that small amounts of iodine are still easily available.
Yeah, I still have my original bottle of iodine that I bought years ago when I started all grain brewing, and it's just a small bottle of tincture of iodine that I bought at the pharmacy, and it seems to work well. Now I use mine undiluted, and I'm going to have to start using it diluted to see what difference that makes in the test.
I found that diluting with rubbing alcohol works better than trying to dilute it with water, because the iodine is more soluble in alcohol, apparently.
Very good.
And you can always test the efficiency, like if your iodine solution is going to work by just making a simple solution of cornstarch and water, and then putting a drop of whatever iodine solution you want in it. If it turns that blue-black right away, you've got it.
Oh, one more thing about iodine. The iodine test only works on cold solutions, because these helices that form the starch molecules, they break up when the starch molecules or these dextrin chains get hot. So I'm not sure if you're ever in a position where you happen to try to do an iodine test on a sample that is still hot. But most people, because they just use small sample sizes, they don't have this problem because those samples cool down very quickly.
Well, why don't we start into our data, into our results? Zot, since this is your fault, this is your idea, why don't you start?
Okay. First off, I was just absolutely floored by the number of testers that sent in data, and the many of them actually did multiple tests, and they also did it across a variety of styles, which was very impressive, and a variety of grist bills. So the results that we have pretty much represent a good cross section of what you might be brewing at any given time. It included at least one non-standard ingredient of sweet potatoes, which I felt was important as well. The overall picture is it's not very clear. There's definitely, if you take a kind of a normal distribution approach to the graph, there's definitely an indication that the iodine test, the starch test, is showing positive somewhere between 15 and 20 minutes on a majority of the cases. However, by majority means there's still plenty that went past that point, and there were plenty that were actually still showing results out in the 45 and 50-minute range. We did see some differences of when the samples were stirred versus not stirred, but chances are good that the difference between stirred and not stirred is somewhat questionable how much you can test a not stirred sample. There is at least one home brewer who submitted testing from the bottom and the top and was getting different results, which is to be expected since there is stratification within the mash. So I think the short answer is it seems that in most brews the starch test was positive before most of the people's mashes were done, and it seemed that stirring did tend to indicate an earlier starch conversion. However, for people who turn in lots of data, including things like temperature and bricks, stirring clearly dropped the temperature of people's mashes quite a bit. I drew up a bunch of pretty charts from your data, James, and a couple others that you could just see when stirred, the rate of the temperature just plummeted when stirring. So what's interesting is that might still be happening within the mash tun, that stirring may be introducing some cold air, or maybe that there's you're getting heat gradient that you're not aware of within there. So perhaps a test of heat gradient, which would be pretty difficult for most people to do, would demonstrate that. I think the truly amazing thing that came out of here was just the amount of effort that homebrewers put into this, and we had a total of, as you said before, 20 unique brewers, including ourselves. But thanks to some heroic efforts, we actually had 51 unique tests submitted. My favorite is we had 2 PDFs formed with their own graphs already, and 2 videos actually created around this. And for people who sent the videos and tests in, from when I was analyzing it, I was seeing kind of what looked like a normal distribution as I was entering the data. And I was pretty tempted when I saw somebody mark something at 50 minutes ago, well, clearly they messed up their iodine tests. And then I see the follow-up mail with the picture in it, and I go, nope, clearly they had starch in their test at 45 minutes. And the combination of the two say that there's actually pretty good data that shows you may or may not have starch conversion at 40 minutes. You can't make any assumptions based on this. So the answer is it's not clear, but it did appear the starch conversion happened pretty early on, though for reasons that Kai said, it's somewhat questionable as to whether you can make any real judgment as to is your mash really done at that point.
Now, what did you see from your personal experiment? Was there anything that surprised you? Yeah, and you did what, a series of 3?
So I did it originally right after Chris had made his comment online or on the podcast, and so therefore my next beer, I decided, well, if I'm going to recommend this as an experiment, I ought to try it once myself. And so as per my blog, I went out and I grabbed 2 pill boxes, set the experiment up, and I think the thing I learned there is don't try this on a pumpkin beer, because I was making an actual pumpkin beer where I was mashing real pumpkin, and I'm pretty sure that pumpkin was just leaching out starches and sugars and pumpkin fiber and bits of seed all throughout the mash. I think I wound up mashing that for past 75 minutes because the starch test would be clear, then the next one would be solid. So don't do it on pumpkin would be the first thing I learned. I then did it on an Irish red, and I actually came up with pretty solid results. At 10 minutes, it was done. Huh. And that was a pretty straightforward 5 pounds of, 5 kilos of pale and a few other adjuncts. And then I did okay, so this is my experiment. Guess I really ought to do something big here. So I decided to do 3 in a day, and I did 3 1-gallon batches. And clearly, I learned that trying to do measurements and temperature measurements while watching my kids, and apparently succumbing to the flu was somewhat a questionable scientific practice. Some of my results, I look back and go, that can't have happened. But what I found there is what I did there is I actually did 3 1-gallon Brew-in-a-bags, and I pulled one batch at when the starch test went at 20 minutes. I pulled the next batch at 30 minutes, and then the next batch at 60 minutes. And I'm fermenting those right now to create 3 beers with the exact same grist bill. I've ground it all up and mixed it all together. So I'll actually hopefully have a taste test at my next homebrewers meeting of can they determine which beer is which. The obvious one at pulling it right at 20 minutes, that's kind of early. But is there a big difference between 30 and 60 minutes on this particular bill? I also did notice when my thermometer was working, because the battery died midway, that in one gallon batches, you don't have as much thermal mass, and your assumptions about using your pot as your mass ton may not be very smart.
Unless you can apply heat.
If your thermometer goes, you really don't know how much heat to apply.
Yes.
And so I decided to keep consistent and just let it drop. So while I took gravity measurements, they're completely useless since they're only relative to themselves. But I definitely felt like not stirring the mash. I just was staring at it going, I'm clearly seeing the stuff move around the mash. And from just a scientific and, just from cooking, it strikes me that you really want to stir it. But seeing your data about the temperature drop tells me that, there's perhaps really good reasons not to.
So Kai, tell us about your experiences. What experiments did you do for your contribution?
My contribution was a simple one where I brewed an IPA, and that was I believe it was mashed at 68 at 68 degrees Celsius, or 154, I believe, and I saw the iodine test being negative after 30 minutes, but I also kept track of the gravity of the liquid in the mash, and I saw that continue to rise until I started sparging, which was after about 70 minutes. So it seemed that it confirmed what I have thought before, that the iodine test doesn't really tell you necessarily when you're done mashing. It just tells you, well, there are no large dextrins or starches in the wort present anymore, but there can still be conversion going on in the mash. Let's say, for example, pulling from large pieces of grit, of grits that still contributes to the amount of sugar and dextrins in the wort, and thus raises that gravity of that wort.
Yeah, and that was reflected in, there were a few brewers who also did gravity readings throughout their mash as well, and that was reflected in their results as well, in that even past the point where the starch test turned negative, the gravity of the wort kept rising. So if they had used the starch test as an indicator that their wort was finished mashing, they would have lost out on harvesting those sugars from the mash.
Yes, exactly. So these are the gravity of the mash liquid, or the sweet wort in the mash, is an indicator of how much of the grain's weight, or particular the grain's starch, has been converted into sugars and dextrins. So, and the most you can get out of the grain is generally about 80% of its weight. That's where you generally have the extract potential of two-row. And so, together with the mash thickness, you can come up with a gravity number, or an extract number that represents the most that you can get out of it. And in my case, where I had about 3.5 liter per kilogram mash thickness, or 1.64 quarts per pound, that maximum gravity was about 18.5 Plato. And I did reach that after about 60 minutes. And at 30 minutes, when I considered the iodine test to be negative, I had realized about 95% already of that potential.
Ah. So, Chris, what since your observations are still fresh in your mind, Chris did his term paper the night before it was due, figuratively. What did you find out? What test did you do, and what did you find out?
Yeah, I've just completed my test today. I'm just saying.
You're not one to waste time.
No, very
well. The data's better fresh.
There you go.
It still smells good. It's got that fresh from the oven smell right now.
Do you have like a fresh data sign that turns on like Krispy Kreme outside your house?
I do. Yeah, drive by my house. It's fresh data.
So what does that fresh data smell like?
Well, I actually went to my homebrew shop today. I got a variety of grains. I only had time to test 2 of them. I made mashes from 6-row malted barley and 2-row malted barley. At each of them at 2 different temperatures. Small sample mashes on my stove. So I had basically 4 tests. The liquor to grain ratio in both of these was 1.375 quarts per pound of grain, and both of them were stirred. So my sort of idea here was that these are basically the a stirred mash with a reasonable liquor to grain ratio. Plus, I made sure that the mash liquor was of a sort that was appropriate for a light mash of just these grains. I was looking for sort of the best possible, what's the fastest time you can get conversion. And what I found was, I tried 6-row malt initially at 158 degrees Fahrenheit, sort of at the high end of the starch saccharification range, and had kind of flaky results. The first test after 5 minutes was still black, indicating the starch was present. After 10 minutes, starch test was negative, indicating that, complete conversion had occurred. But then subsequently at 15 minutes, I got another black result, that starch was present. And this may be due to, I think, a little bit of a chunk, like a little grit of, starch that hadn't dissolved got in the test right there. So it's possible that the complete starch conversion at 158 degrees with 6-row malt, which is, supposed to have a lot of diastatic power, occurred between 5 and 10 minutes, and that the 15 result was a fluke. But, it's also possible that the 10-minute result was a fluke. But after that, I got solid negative results for the 6-row. So I repeated the 6-row experiment at 150 degrees, sort of at the lower end of the saccharification range. For the 5 and 10-minute tests, I got, black results, definitely. There was starch definitely present. And for 15, 20, and 25 minutes, I got, negative results. And in all cases, in the 6-row data, as time went on, the amount of extract increased over time. I got, for example, at 5 minutes in the 6-row data at 158, I had a reading of 15 bricks on my refractometer, which is about, 1.060 specific gravity. Roughly, it depends on, there's some conversions you need to do. And then that rose to about 20 degrees bricks over 25 minutes. Likewise, at 150, it started at about 14 bricks and rose to 19. So, as you said before, in some of the results that other people had seen, the negative result that you end up getting a starch negative result happens well before you even approach the amount of extract you're going to get from your malt. And then the two-row malt was very, very similar. At 158 degrees, I had black results, positive starch detection up to, 15 minutes. Then for the 25 minutes and beyond, they were negative. And at 150 degrees, I had positive results up to 25 minutes. And then from 30 minutes on, they were negative, indicating that the starch had been degraded. And again, I had the, start out at lower Brix ratings, went to higher Brix ratings. So, I think the nice things about the couple of tests I did so far, 6-row and 2-row, is I just used the plain, I just used the base malts. There were no other specialty malts. There were no other adjuncts or whatever. I used them alone. It was a stirred mash. I did this on my stovetop where I was heating it to keep it at the same temperature. And I mean, I think what my iodine test shows sort of the minimum amount of time that you would get conversion as a home brewer. And then, subsequently the gravity readings, that I did by refractometer show you that even though you hit, complete starch conversion as indicated by the iodine test, your gravity is still going to go up after then. So if you're looking to get the most from your wort, extract wise, you don't necessarily want to start, running off to your kettle when you hit, an iodine negative result, because you're still going to pull more extract if you sit and stir it for a little while longer.
Yeah. I got similar results from my two tests. I did one unstirred and one stirred using 2-row, a bit of crystal, some aromatic, and some chocolate malt. This is for a hoppy, not-so-pale ale. And it was both of these. What I did was I split my mash into two and did a brew in a bag. And I took my gravity readings off of the top of the wort. And in the unstirred, it stayed pretty much constant at 3.5 Brix through the entire mash. It came up a little bit at the end. But the stirred one came up step by step through each 5-minute period throughout the entire mash. So that was a good indication to me that if you want to get a good indication of the gravity of your wort in the mash tun, especially if you're doing it brew in a bag where you can't pull off the bottom if you don't have a spigot on your kettle, you need to stir it. Both of the batches, the stirred and the unstirred, converted. They showed a negative starch indication at 25 minutes into the mash. The other thing that I found was interesting was that the temperature in the unstirred mash, since I had my kettle on the hot stove that still retained some heat from the fire being on, the temperature in the unstirred mash actually rose a little bit during the first part of the mash. And the stirring, as Zot mentioned earlier, the stirring really had an impact on the temperature, bringing the wort down the mash down from 153 Fahrenheit in the beginning to 138 in the end. And again, to reiterate, I had a negative starch indication at 25 minutes into the mash, yet for the rest of that 60-minute mash, my gravity readings rose. In fact, if I had quit at 25 minutes into the mash and pulled out the bag, I would have gotten wort with a gravity of 9.6. At 60 minutes, it was up to 12.4. So that's quite a bit of sugar to leave behind in the bag. So that's kind of what we did, and I will later on read the names of the of the rest of the brewers who participated, and we have to say that we don't have time to do everybody's data justice in this program, but there's going to be a whole lot more space in Brew Your Own magazine to give some more flesh to the bones that we're putting out here today.
Right. This is the experiment that we've got the most feedback from our people, and it's also one of the most objectives. I mean, it's not based on people tasting things and giving their interpretation. It's based on, an iodine test, which, although as Kai mentioned, there are subtleties to it, is fairly objective, and there's certainly, it's based on either refractometer readings or hydrometer readings, which are relatively objective. You can be off by a little bit depending on how you read it, but it's fairly objective. So we've got a lot of people contributing to this experiment, and we've got a lot of data. So yeah, this is going to take up some real estate in the issue of BYO that it eventually appears in.
Now, some of the guys I want to mention, like John Welburn did 2 tests, Ken Valley did 2 tests, Brandon Dufala did 2 tests. Not only did Brandon do 2 tests, he videotaped and edited elaborate videos and put them out there on YouTube of his tests and his results, and I thought he did a great job. And in fact, I've asked Brandon if I could link to those videos from my website. So if you look in the description of this episode on basicbrewingradio.com, I will link to Brandon's videos. But I guess
that was amazing.
Yeah, they're beautiful.
Yeah,
beautifully
that was cool.
done. And it was interesting because he kind of shows it warts and all, warts and all, warts and all,
warts and all.
I didn't mean to do that, but you can actually and kudos to Brandon for putting himself out there, because that there are going to be people who comment on his video on YouTube. You didn't do it right. You should have done X, Y, Z. So kudos to Brandon for doing that, and be nice to him if you.
Hey, maybe that'll be the next experiment. That's how I got here.
See how you can criticize Brandon. But I guess
one thing about doing the actual experiments is it's always harder than it looks.
Yeah.
People whenever you suggest an experiment, people are always saying, "Well, you should have done this, this, and this," and people are always critical, but it takes time and effort to do an experiment.
Exactly.
And things don't always go right. And I mean, just tonight, when I was at the last minute doing the experiment, I had to fiddle around with how I was doing the iodine test exactly, because I was getting some confusing results early on with, how much iodine did you add and just how much color did the iodine itself add to the test. And so, it takes time and effort to do good science, and good for him for showing a video where, maybe he didn't get everything right on the first try. But, not getting everything right on the first try means maybe you learn from it and get everything right on the second try.
Now, I guess the hero award might go not that everybody, I think everybody's a hero, but I think if you hear what Chris Wolf and his team did up in Kansas City, Missouri, Chris Wolf solicited help from his brother-in-law, Bill Beggs, and Chris's daughter, Rhiannon. Chris decided that he was going to do this test, and I believe it was Chris that said that he said he didn't, on the previous experiments that we've done, he said, I don't feel comfortable enough with my palate to get involved in contributing subjective information, such as whether a beer tastes good or not. So he said that he was really interested in this one, this experiment, because this is objective data. So what Chris did was he went out and he bought Pilsner malt, American 6-row, Munich malt, Harrington malt, and Maris Otter. Okay, so that's 1, 2, 3, 4, 5 malts. So already, he did 5 tests, right? No, he and Bill and Rhiannon did one series of tests, all of these malts at 142 degrees. So that means he did 10 tests, right? Or 142 degrees and one at 158 degrees. So he did 10 tests, right? No, they broke it down into each one of those unstirred and stirred. So we have Pilsner malt, at 142 degrees Fahrenheit, unstirred, at 142 degrees Fahrenheit, stirred, 158, unstirred and stirred. So we've got 20 sets of data from Chris and Bill and Rhiannon. So we have to give them extra kudos for that. And I think that if you look at his data, that we can see some of the trends that we're talking about with our tests, with his as well. For instance, if you look at the Brix reading on the unstirred malt or the unstirred mash, they are really low across the length of the mash. And by the way, they did like 90-minute mashes on it. I don't know how they did it. And
I thought I was doing really well for going for a trifecta. And when you sent me these results, I honestly couldn't even conceive of that he went and did this. It was just amazing.
Yeah, that's awesome.
But measuring unstirred wort from the top is not going to give you a good indication of the gravity of a wort, because that shows in here as well. Also, it appears that for the most part, a stirred mash will show conversion through the starch test later.
Actually, one thing I want to add, if ever somebody goes to repeat that, I'd really love to see that unstirred mash being stirred up at the end.
Oh, okay. Yeah.
So that we can get an even that we can distribute all those sugars and can get a Brix reading that is indicative of how much has actually been converted. Was the unstirred mash really that much less efficient in starch conversion than the stirred mash?
That's a good point.
Not?
That's a good point.
One other point is that every commercial mash is stirred. I mean, every or almost every. Just mixing up the grains just helps. It just moves around the starches. It moves around the enzymes. It moves around everything. And as homebrewers, I mean, we all do at some point have done unstirred mashes, but it really helps to stir it, I think.
In Germany, there's even a company, a mash that makes a mash tun that has a built-in vibrator, so that actually vibrates the mash. And they say that actually even helps with the speed of conversion, because you have these vibrations that help the water to get into the grit particles, and it helps things to get extracted faster. I thought that was pretty cool.
And kudos to Chris for not inserting a Charlie Sheen reference right there.
He's gone a pretty long time. That's not bad.
Yeah, I've gone the whole podcast without making a Charlie Sheen joke.
Now, looking at Chris's data, Chris Wolf's data, Kai, you've made a chart, a beautiful chart, mapping his data points. So, what can you, how can you communicate over audio? Kind of the thrust of what that chart shows.
Well, I only made the chart for the Brix numbers for the stirred mashes, because as I said, for the unstirred mashes, they don't really mean much. But for the stirred mashes, they are an indication of how much of the extract has been extracted from the malt and is now soluble in the sweet wort. And one thing you can see is that the hotter mashes, the extract rise over time is steeper, and at the end, when he stopped mashing, more extract was converted into dextrins and sugars compared to the colder mash. So he was using the hot mash in his case was 158 degree Fahrenheit, and the cold mash was 142 degree Fahrenheit. And within this group of hot and cold, there is a clear difference between the malts. In particular, for the hot mashes, the Pilsner malts led followed by Harrington malt, another Pilsner malt, then the American 6-row, and the last one, the one that didn't get as much extract and where the decline was not as steep, was a Munich malt. That the Munich malt is last. That is kind of expected because it is known to be an enzymatically weaker malt because it's kilned hotter and it doesn't have as many enzymes. But I was surprised to see that the American 6-row did so poorly compared to the Pilsner malt he was using. Because American 6-row is known to have a large enzyme content, and I thought it would at least be on par with the 6-row.
So let me go ahead.
American 6-row also, though, they're thinner husks. There's less starch per there's less carbohydrates per unit weight than other malts because it's just less plump. Although
that's a good point. I didn't take the actual extract potential of the malts into consideration here.
Yeah, 6-row is very, very enzymatically active, but it's on average slimmer than 2-row malts. There's less starch per husk than 2-row.
So let me toss out this question: if the iodine test for starch conversion is not an indication of when the mash is complete, or not an accurate indication of when the mash is really complete, what good is it?
I can give an interesting answer that came up orthogonally on a newbie brewer posted that he had tried to do a partial mash, and but his gravity points were quite low, and I was able to. I recognized the grist bill pretty similar to what I had done, and he had mistaken doing a partial mash for specialty grains. And what's interesting is very clearly the points he got came from his extract, and he got absolutely no points from basically a to mash well cooked crystal 120 and some chocolate malt. And had he done a starch test, he would have recognized the fact that he was still fully starched at the end of that, and that something was wrong. And it basically is not an indication that you're done, but a positive starch test is an indication that you're not done, or you've made a big error.
That's a good way of putting it.
A starch test it's one piece of information. It's not the end all be all of mashing. It's it's telling you that in the sample you've pulled, there are not detectable starches by this test. And you've got to use it's one of the many tools that brewers have to use to determine what their mash has done, but it's not something that you would say like, oh, starch test is negative, I'm done.
So if you take a starch test 30 minutes into your mash and it's negative, you're not necessarily done. But if you take a starch test at 60 minutes into your mash and it's positive, then you're not done.
Yes.
Yes. So, what's my common practice when brewing is just that when I'm done mashing after, let's say, 60 or 90 minutes, I quickly make a starch test just to say, oh yeah, it's fine. I don't have a problem here. And then also I tend to take a refractometer reading and put that into a correlation with the mash thickness to see, okay, did I realize or did I get the extract potential that I was expecting from the grain? Because if there was a problem and I didn't really extract as much from the grain as I was expecting, then obviously my overall efficiency will suffer. And at this point, if I find that actually there is still a lot to be gained, I can take corrective action, and that corrective action might be to mash a bit longer, to add what people call a mash out, but it's generally just a dextrinization rest where you raise the temperature and potentially infuse more water to just try to boost the alpha amylase to just get more starch converted, or I'll just prepare for lower efficiency.
So the starch test is one tool in our toolkit, and if we know how to use it and when to use it, it can be useful.
There's very little. Just want to interrupt you. There's very little use in actually trying to do this every five minutes and finding the point when actually have a transition from negative to positive, or the other way around, from positive to a negative. Again, it's just, I think just at the end you do the test, and just as a safety measure.
Yeah, any newbie brewers out there who think that the way you do a starch test is to do it every 5 minutes during your mash, let us not mislead you.
I apologize now to the future people who hear this podcast and suddenly discover it was just an experiment.
Yeah, that'll punish them for not listening all the way to this point. Well, guys, like we said earlier, lots more detail can be brought out in the BYO article. I want to thank you three, and I want to thank all of the rest of the 16 folks, along with the rest of Chris Wolf's team up in Kansas City for participating. We've got to put on our thinking caps and find the next experiment. You know, maybe we carry on from this point and find another, kind of iteration of this kind of thing, because it's apparently easy to do and popular, and I hope that people will find it useful. So thanks, guys.
Well, you're welcome.
Thank you, James.
I want to say thanks again to Chris Colby, Zot O'Connor, and Kai Troester, and I want to thank our participants. From Wirral, UK, John Welburn, Brian Davis from Lisle, Minnesota, Nate Muller from Seattle, Washington, Denny DeWalt, Fayetteville, Pennsylvania, Ron Evans, Verdigris, Oklahoma, Jeff Karpinski, Elizabeth, Colorado, Sean Terrell, Silverton, Colorado, Ken Valley, Iowa City, Iowa, Ron Harmson, Owasso, Oklahoma, Mark Greer, Nashville, Tennessee, Peter Hoyam, Pipestone, Minnesota, Chad Schaefer, North Point, Florida, Eric Streckfuss, Washington, D.C., Tony Milner, Wallace, UK, Brandon Dufala, Greenville, South Carolina, and Chris Wolf, Kansas City, Missouri, and Chris's team, Bill Beggs, and Rhiannon. Thanks, everybody. Just incredible. And if you somehow submitted data and it didn't get to me, and your name was not on that list, please send it to me, and we will get you your data in for the magazine article, and I'll mention your name on the show as well. Zot has done us a great favor of compiling a PDF overview of the results, and you can find a link to that in the description of this episode on basicbrewingradio.com, and I'll link to it from our iPhone and Android apps too. And Zot says he's working on a blog post on his blog on the experiment, and when it's up, I'll post a link to that as well. And I'll also put links to Brandon Dufala's videos on our site, and I'll share my photos of my tests so you can see what those look like. Awesome experiment. Just wonderful, and I can't wait until the next one. If you have brewing questions, show suggestions, or just want to say howdy, write to james@basicbrewing.com, or just fill out the contact form at basicbrewing.com. Please don't forget to tell us where you're from. Our DVDs are on our website: Extract Brewing and Partial Mashing, Stepping into All Grain, Low-Tech Lagering and Decoction Mashing, and Introduction to Wine Kits. And we got combo deals on our site to save you a few bucks if you want to buy more than one DVD at a time. And you can check out our Basic Brewing shirts in the store too, along with our 2011 Brewers Logbook too. You can see a listing of the fine folks across the country who sell our DVDs on basicbrewing.com, and if there isn't a vendor in your area, you can order them online in our online shop at basicbrewingshop.com. Thanks to everybody who's continued to click on our Amazon.com link. We appreciate the support there. Our featured products this week that were purchased through the link are Satiristas, Comedians, Contrarians, Raconteurs, and Vulgarians. Sounds like a family reunion at my place. And Smack Dab Cover Secure Clip for the Kindle DX/2/3. Thanks again, everybody. And remember, I can't tell who bought what, so no worries there. Just click on the Amazon.com logo on our site the next time you feel like Amazon shopping. We appreciate your support. And don't forget, you can also join the American Homebrewers Association or subscribe to BYO Magazine through an associate link on basicbrewing.com. That's all until next week. Until then, thanks for listening, everybody. I'm James Spencer. Production help for Basic Brewing Radio and our website is provided by Kelly Dodson down in Austin, Texas. Basic Brewing Radio is a production of Active Voicing. We'll talk to you next time, everybody. So long.
I'm high on Charlie Sheen.
Okay.